So after just about 7 weeks of framing, there it is. Finally just finished up with the real framing work. And that is $45,000 of lumber and hardware and another about 25 in labor costs for the 3 framers for 7 weeks. And so a lot of money to get it to that point. So let me bring you in a little closer. So a couple little things I did that I didn't really have to is totally plywood the exterior. Furred it up as the inspector called it. Some of this plywood absolutely had to be here for shear engineering stuff, but not all of it. Although now that it's all plywood, it's a lot nicer. Put the plastic up on the windows because we had a pretty bad rain, and I went with the shorter 12-inch eaves. The reason is they'll match my house, which has a like a corbel molding that's gonna go there. Here, this is high fire zone. That burned once, so it's a little bit different, almost like a Monopoly house kind of look. But once the foam detail goes up when they do the stucco, it looks really good. So here's pretty much just a tour of the outside. I got a couple little things to do, but I'm just gonna do some stuff myself. Like there's some nails that were just put up to get the next sheet of plywood up, so you can just barely see them in there. Maybe a few of them. So I'll pull those. And this was one of the more complex things that I had to really try to work out. These being shear walls needed to be nailed, at specified distances with specified wood members to support the level of nailing they required and all that stuff. So that was a bit. This one called for 4 inches, and same with that wall. And so here's what we got with the deck. So again, we're at 2,000 square feet of garage space inside, 1,000 square feet of living space, and then 600 square feet of deck and 600 square feet of covered porch. So there's the main entrance, which is going to be like a double French door. That's what it's framed for. You'll notice a lot of these Simpson shear wall, strong wall pieces. So there's 5 for the deck. There was 2 for the front lower, 2 for the front upper, a stacking kit. This was a lot of work. And the deck seems like maybe overkill, but the deck was called out for micro lam. They gave us an option of micro lam beams or TJIs, and originally I had a lumber list made up, a lumber takeoff, and they on the list they made it micro lam beams. So these are not 2x10s, these are micro lam beams, every single one of them, with special hangers here and the rim joist out here. And that was a Paralam rim joist, and a lot of stuff. So this deck could probably realistically support a hot tub without a problem. Don't plan to do that, but it probably could. This will all be stuccoed and put some ceiling fans and some lights, and this will be like a covered porch. And then we'll even head up on the deck next. And then you can see, this is more or less just a lot of wall here. These are 10-foot sections of plywood, 4x10s. So yeah, you're looking at close to 30 feet there with the 18-foot eaves, some outside power. And so I did the really tall windows to try to not make the building look so massive tall with the 18-foot eaves. So these windows actually come up to 10 feet. So the top of the windows are 10 feet. So from a distance, it doesn't look as tall. That was kind of the goal. This is my favorite little feature. We use this rock. This is permitted and approved. They had to do engineering on it, and I had to have a witness come out and verify that I cut 7 inches into the boulder, drilled 12 inches into that, and then epoxied 18-inch hardened steel rods in there. So that was its own thing. So I'll go ahead, I'll run you up on the deck. We could go to the deck through the stairs, but I've got all the doors taped off and plasticed up because it's windy, and we had 2 inches of rain just the other day. So let me pause you while I run up this ladder. All right, so here's the deck space. Laid the ladder down because it's just so windy. Got a little block for safety. So this is that 600 square feet here. And you could do like a railing. You know, that's not really part of the framing, so I cut all those guys loose. But you can see a lot of plywood. And I popped this door opening open, so we'll go ahead and just jump right in here. So here's the living space. It's got the vaulted 10-foot ceiling. I think it's actually a little over 10, 12-ish. Some big picture windows here. That one will be where the kitchen sink is. That's out to the deck. And this was optional, but we went for it. So that's out to the deck as well. They made me do a pony wall here rather than like a railing kind of thing. And these are the stairs that go down to that main entrance. We just were over there. So this will be the living room and kitchen kind of combined area. And this one is a little under half. So that'll put us, I don't know, this one maybe, this is probably close to 500 square feet alone right here. So it's 20 wide, and yeah, it's probably close to 600 square feet. It's probably about 30 by 20. And then right here, this is framed out for a pantry, because this will be the kitchen corner right here. And then this is not a door, but this is just a hallway with laundry room kind of area. This will be the master bathroom, and it's got a recessed shower. So the shower will actually be tapered to the wall. There will be a channel drain right there, and this will be like accessible by wheelchair or roller or whatever. And then I just started kind of putting up this attic flooring because, you know, it's actually pretty nice usable area up there. This is the master bedroom. So again, got 2 nice big windows. You can see here that this is the strong wall that's stacked all the way to the bottom. Got special brackets. We got a ton of these HD4s and HD5s, all clamping everything down. Everything is 2x6. Every exterior wall, I should say, is 2x6. The interior walls are 2x4. So we're going for R19 insulation on the walls, plus I'm going to do the rigid foam board on the outside, which is going to add it almost like 5. So it'll be like R23 to 24 by the time we're done. You can see another strong wall here, right there. And that one's already blocked out for drywall. And then here, again, another big, heavy, strong shear wall. I don't really know what they do in other states. You know, when I was a kid, I don't remember every construction job looking anything like this. But now that I'm in California, everything seems kind of overdone to me. But, you know, this called out, you know, a heavy post with the HDU5, you know, all the way up. Another hold down, and those go through the floor, and they couple to inverted ones on the bottom. So again, even this wall is 2x6 because outside of this wall is garage space. So we wanted to have a lot of room for a lot of insulation. And then the whole ceiling is TJI, they're truss joists. These are TJI 230s. These are. Beneath me are TJI 360s, but these are TJI 230s. So they're interesting. It was actually, these were cheaper actually than doing a 2x10, because if it were a 2x10, we would need to do them on 16 inches. So because they're an engineered truss joist, we're able to spread them to 24. and this will carry the full load of the clay tile and everything. And then the sheathing, called out mandatory by Title 24, needed to have that radiant barrier, so that's why it's reflective. And then, yeah, needed double top plates. I'd imagine a lot of that stuff's probably fairly standard. So there was a lot of little details here. Even these, we needed to do a 3x6 to accept the correct number of nails for the shear panel, and same with the blocking, because these need to be nailed actually on 4 inches. So on this plywood is 4 inches, on this plywood is 4 inches. So that means they're like 2 inches apart. So a 2x6 wouldn't have been enough material to take all those nails. So that's why you see there's a lot of 3x blocking and 3x members and 4x members. So we'll head down. So got a lot of these LTP 5s, and geez, I didn't even look, but there's an unbelievable number of Simpson A35 framing angles. You can't quite see, but every single blocking of this it's not really a rim joist, it's actually blocking. The rafter lands right on a nailer, which is on top of the double top plate, and then these micro lambs are blocks in between, and they have an A35 on every single one. And then there's A35s on every single one of those. That's not blocking. That's a solid ridge pole. I believe it was a 2x14 micro lamb beam all the way, and each one of those got A35s, and then on the top they've got straps too. Every other one got a strap. There's a lot of hardware in this building. So let's get down there. That took some time. Those are pretty hard. Oh, and then on the edges, because it's a TJI, we basically tied in these 2x6 outlookers. So these are tied into the end and blocked with additional plywood, and the nails go through the plywood, through the webbing of the TJI, and into the outlooker 2x6, and those go out the 12 inches to give us our eaves. And again, double blocking all over the place, and fire blocking, and engineered beams, and a lot of that. A million hold down bolts, I swear. The stair stringers, because we wanted to go with something slightly different than what's normal, we just went ahead and started with a 2x14 by 24 foot long micro lamb, and went ahead and did our rise and run and calculated how many stairs and all that stuff, and just custom cut the stringers, and then put in a 1-inch plywood as the tread, and then a 1/2 inch as the riser. And so this right here is gonna be a little storage area. This right here is gonna be the downstairs bathroom, kind of like a shop bathroom in a way. You just see lots of hold downs. Got the underground piping in for the sewer. There's a little toilet flange under the sink. Again, tons and tons of engineered beams and plates, and these eccentric saddles, and another one here. Looks really yellow in here because that plastic is yellow. But this beam actually could have been a little smaller. I believe we went with a 6x10, even though we only needed a 6x8. So when we went with the 6x10, we actually routed in a little bit to be able to have it accept the correct saddle. I'm gonna go through and notch out some of this plywood. The plywood won't sit all the way because it's on the steel, but at least we got it up as a solid piece. And then similar down here, routed. And both of these ends have the eccentric saddles, and then this huge Paralam beam. Actually, it's two pieces. It overhangs into there, comes to the midpoint, splits, gets a plate on top, and then continues. And then these are those TJI 360 truss joists, or floor joists. And so, and you can just get a little peek of just how many 835s there really are here. So you can see on every block an 835. They're all over. And then each of these needed to have a hanger. We couldn't do a ledger here. These are set right into the wall, but these ones that came to the beam needed their own hangers. So a ton of hangers. A ton of hangers. I think each of those hangers was, oh shoot, there's been so many. Some of these hangers were $6 and some of them were $11 a piece. And there's a lot of hangers in this building. And same LTP5s with the double top plates for the shear wall. There's the inside of that Simpson strong wall. This is the 24-inch strong wall. And then here's the stacking kit. And then each strong wall has a plate, and that ties in the top plates to the strong wall. So a lot of nails in there. And those are the Simpson structural nails they sell, their own brand and stuff. Same, another strong wall here. And then that's where you notice we've got the inverted HDs here. So those bolts were already embedded. Again, 3x6 members over here. And this is actually the shear panel schedule. This is number 3. So we're looking at sheathing applied with 8D nails at 4 inches on the edges and 12 in the field. So that's why that board is thicker, because 4-inch nails. These are fine, it only needs 12-inch, and this is another break between this plywood and that plywood, so we needed the 3x6 rather than a 2x6 to be able to accept all those nails. Same with that one. And so, there's a lot of, not really a whole lot of waste, but some waste. Each of these micro lambs is $4 to $5 a foot. So that's $5, $5, $5, $5. It's a lot of money, but you got to do what you got to do with it. You can't get them ordered exactly perfect every time. And so, a lot of that has been quite a learning experience for me. There was a couple bolts when we set the hardware foundation stuff. It seemed to me that this bolt for this HD would count as a hold down bolt, like an anchor bolt, but it doesn't. So there was a spot, matter of fact, it was this one, where I thought it needed them to be on 42 inches here. So that one to that one to that one, I thought I was good, but it turns out between this one, that one doesn't count, and that one, it was too far apart. I had to add that later, which meant, actually, it's a different one. I added that one. So I had to add a couple here and there. That could have saved a little bit if I were to, have for sure understood the bolt layout a little bit better on the shear schedule, and realized that the hold down big bolts that are like 24 inches embedded in the concrete don't count as the same as the little 12-inch anchor bolts. You can't count the hold downs as an anchor bolt. Seems weird to me. So I had to add some here, but I basically had set everything to 36 inches from bolt to bolt to bolt, but also thinking those counted, I ended up having to add a few. So that was, that's not really super hard. There's videos from Simpson on exactly how to do it. You drill it and clean it out and epoxy them. These had some bigger hold downs. It's an HDU 11. Go into that engineered post, and then this one's too buried. There's another HDU 11 going to a post in the corner. And then you can just see a lot of LTP5s. Every single block has a Simpson A35. And then the LTP5s were called for at 36 inches on center on this wall, because this wall was a shear schedule number 1. So that is 6-inch nails. So we didn't need to do the thicker members. We could just use straight 2x6. And the anchor bolt spacing was at 60 inches on center. So actually I placed these much tighter than I needed to, but this is as I was learning kind of how things went. But I have them on 36 and I could have spread them way out, saved a few anchor bolts there. But it's kind of overdone, but I'm okay with that. And same, lots of hold downs, a lot of stuff. Now this big wall right here, this section and this section are required for shear walls. So those needed to be plywood. They need to be nailed on 3 inches on center because those are number 5 shear wall, all per the engineering. This whole area here, I didn't actually need to plywood, but you know, it's just kind of like, this is going to separate the garage space from the living space. So I'm good with plywall and a lot of insulation for noise and you know, temperature and everything. So to me it seemed worth doing plywood on everything. It cost about an extra $3,000. No, it was more than that. It was about $4,400 in extra plywood to plywood everything. Otherwise, there would have been plywood on this shear wall, this shear wall, this shear wall, no plywood here, no plywood here, no plywood here. Actually, there would have been plywood here, but no plywood there, and no plywood there, and no plywood here. And that would have been fine because it would have ended up getting stuccoed. But it just makes more sense to me. The stucco is going to turn out better. Of all the things to try to save on, that's not really what I would try to save on. Mostly, I wasn't able to cheap out on much of anything other than not hiring a general contractor and not just having someone do the job as a bid. I got bids. Materials and labor came in close to $100,000 to frame this, and we didn't even talk about furring the whole thing with plywood. So if I got out of it at 70 rather than 100, I'd say it's worth it. Although literally for the past 7 weeks, I've been working out here every waking moment if I'm not literally clocked in at my job. So that helped. That be, in my opinion, the way to save money is just to think kind of smart about how it's going to lay out. Even though these TJIs are more money than a 2x10, it allows you to spread them out further, so it's not really more money. Although, like my framers were not really excited about using them. They kept trying to talk me into 2x10s because the 2x10s would have been easier to block. So each one of these that need to be blocked need to have matter of fact, this was our template one right here. They need to have these blocks kind of made up like this with the little cutouts to clear the webbing of the TJI like that. So it's kind of an I shape. So each block needed to be cut out. That was extra labor for sure. So it's hard to say if it really saved money to use the TJIs versus the regular lumber. But the TJIs are all they give all the engineering numbers and everything. So those are probably easier for the architect to use and everything. But I'm sure I've missed a million things. But that's the gist of what about $70,000 and about 7 weeks of time has gotten me. Not counting anything to do with concrete at all. And, this is what I'm working off of. And it just got, this is my approved set with my job card in there. It just got signed off as approved from the county today. So it's all legit. So, don't know if that'll really help, but at least maybe a little bit. And there you go.